I'm going to go over the group analysis from our last data set, and in this module we're going to also fill in later in this module these next two columns of this anonymized data log. So we're going to add in two columns for standing and sitting from today's module using a different type of data analysis while we're recording. So the first thing we're going to do is plot the entire set of data here. So I've actually I've made this a read-only file, so we're actually going to have to make our own copy, and we're going to have to work from that copy. So here's my copy that I've made of the file, and we notice that there's some really big values, just looking at it, some negative values, so we're also going to work on removing those. So the first thing we're going to do is insert a chart, and we can insert kind of a couple different charts, but I'm going to start with a we could use something like this, a line chart, to look at all the values, but maybe the scatter plot will give us a lot of information, because you can already see that on the sitting some people had negative values, on the standing some people had negative values over here. So what we want to do probably first is remove some of those extreme values. We could create some rule, and we might say that the beats per minute should be between 30 beats a minute and 180 beats a minute at the very extremes, and remove any values that are kind of outside of that range. To make things simple, I'm going to just remove whole lines. I'm also going to remove lines where we only have one value from a person, because we won't be able to compare. So I'll remove that subject, I'll remove this one with these extreme values, I'll remove these negative ones right here, and you'll see that the chart will actually update live. So here is a huge number, 584, that's quite unbelievable. Here's two rows that have very extreme values as well. Looking through your files, there was a couple of reasons people made mistakes. Some was noisy data with no clear peaks, but some other reasons were incorrect calculations, and I'll try to be a little more strict upcoming on what I give you full credit for. This time I gave was pretty lenient. So here you can see someone put in 0 for both values. I'm not sure what happened there. So there we've removed most of the ones that were missing. I'll remove this one that was missing, and this one that was missing, and this one that was missing, and this one that was missing. So now we have 76 values, I think it is. Actually, this is a pretty extreme value up here too, something close to 200. Let's see if we can find that one. We could use some of the tools built in to find extreme values as well if you want, but I'm going to try to do this by hand at first, although it's quite hard to find this. So you could do things like conditional formatting, where you say that if it's greater than 180, then we can color it a certain color, and that'll allow us easily to find this outlier here. So there we go. I think that's roughly our main set of data. You can see here that people have a correlation between their heart rate standing and their heart rate sitting. So we could test that correlation by typing in correl and compare all of these 75 values to the values C2 to C76. And we find that we have a pretty high correlation of 4.45 between the two measures. We could also add in a trend line showing the line that best fits this data, and we can even add to that trend line the equation. So this means that people's sitting heart rate is equal to 0.4 times their standing heart rate plus 39.9 beats a minute. So it seems like their some relationship between the two, and we'll investigate that a little bit more. So what else we might want to do now that we've removed all these outliers is we want to see if people on average had a difference between the two conditions. If you look in the literature, you'll find that for example, in this paper that I'll post a link to, these are out of order. This one here. In this paper, we look at heart rate using both an ECG like we did in class, but also a pulse oximeter and a webcam. And we do the same manipulation between sitting and standing. And we find about a 10 beats a minute increase in heart rate when people are standing compared to when they're sitting. We go on in this paper to look at how people's heart rate changes when they look at scary pictures. And so you might imagine designing your own experiment in which you use the Muse to estimate something like that. So for now, I'll just take this figure and paste it into our spreadsheet here. So I'll say insert image, and I'll drag this one in. So we have a rough estimate of how big our effect should be. And I'll make this smaller. Okay, so oh, and I'll even put a link for you guys. So we expect about a 10 beats a minute difference in heart rate between when people are sitting and when they're standing. And we probably expect that the sitting and standing heart rate should roughly equate to what they were in this prior study, about 70 and 80. So let's go down to the bottom of our sheet here, and let's say that we want to look at the average of B2 to B76. And as you might know, we can also drag that equation over here as well. So it looks like we have about 83 beats a minute when people are standing and 73 beats a minute when they're sitting. So on first glance, it looks like we've roughly matched the findings we had before. Let's even go like this and count the number of subjects we have left, so we have that number handy. So we have 75 subjects with these averages in the two conditions. We probably also want to look at the standard deviation of those values from B1, B2 to B76. And we also want to compute standard deviation, and we also want to compute the standard error. So this is a statistical estimation of the error around the mean if we were to take repeated samples like we did in our class. And so we can compute that by saying that it's equal to the standard deviation divided by the square root of the number of subjects in our sample. And we'll drag that over to this one as well. Oh, actually that won't work because it's going to use a different value for the count because I dragged it over. So we're going to make this A78. There we go. So that's the average, the standard deviation, and the standard error. So we probably also want to test if these two conditions are different. Actually, before we test, let's look at the data more closely. So another thing we can plot with our data is the differences between people's sitting and standing heart rate. So we can compare when they were standing minus when they were sitting, and we expect these values to be on average about 10. Notice to pull that data down, I can double click on that little square. I can go double click and it will pull down to the whole column. And so now I might take these labels and move them over here, and I might drag out these values like this. And for this value, again, I'm going to have to change this to the A column. So it looks like on average, we did get about a 10 beats a minute, almost exactly a 10 beats a minute difference between the heart rate in the sitting and standing conditions. This was our standard deviation and our standard error. So we can now use these values to make a plot, a bar plot. So we can say insert chart, and we can take a plot like this. And we should quickly, while we're here, add a labels on the x-axis, which we have up at the top here. And we also probably want to add error bars. And so unfortunately, Google Sheets makes it hard to add a separate error bar for each bar. But luckily, we can use the standard error of the difference, which is a good estimation of the standard error that goes into our t-test, which is a paired subjects t-test. So we can say that we want to add an error bar. We can say that we want to add a particular value. Unfortunately, different than Excel. In Excel, you could select one part of your spreadsheet. Here we have to actually type the value in here. So we're type 3.57, the standard error of the mean. Oh, the point didn't seem to work. There we go. So there's our little error bars. And so what you can see is that our error bar is spanning a range that's different from 0. So this gives us confidence that we got a reliable measurement here. One other thing we can do to look at all of our data is we could plot all of these differences. So instead of just plotting the average difference, we could plot the whole range of differences. And so here I'm going to actually make a list of random jitters, and this you'll see what we'll do in a second. So I'm going to say that these are equal to 1 plus a random number between 1 and 0 divided by 10. So it'll end up being a random number between 0 and 0.1. So this is just going to give me a long column of numbers between 1 and 0.1, and 1.1. And you'll see what I'm going to do with this. I'm going to plot a scatter plot comparing the difference to those values so that they're all kind of lined up together. So say insert a chart. There it is. And I'm going to take this axis here, and I'm going to say the minimum value is 0.75. And the maximum value is 1.25. There we go. So here I have my chart of all the differences between sitting and standing. So I could even say here that this is the standing minus sitting difference in beats per minute. And notice that those random jitters just kind of spread these values out on this line, so they weren't all tightly on a line at exactly 1. And I hope you can see that the average of these, or the weighted middle of these values, is roughly here around 10 beats a minute. We actually know that the average is 10 beats a minute. But this shows us that most subjects did have a positive difference between sitting and standing, but there were some that had the opposite effect. One other thing we can do to look at all the data at once is, this time we want to just select the values and not the averages down there, is we can insert a line graph for each subject. So I'm going to say I want a line graph, and I want to switch the rows and columns like that. So now each participant has their own line, and on the left is showing their line for standing, and on the right is showing their line for sitting. I'm going to just make a axis title here, which is beats per minute. And the whole chart could be titled something like individual subject heart rate estimates. Okay, so each of you participants was one of these lines. I think that the legend itself over here isn't that helpful, so I'm trying to delete it. But it doesn't want to remove itself, but that's okay. So you can see that on average, the slope of these lines is going higher on standing and lower on sitting. And this shows us that most people, this was the case. Okay, the final thing that we'll want to do to test the difference between our data, sitting and standing, is a statistical test. We want to do a test of the difference between standing and sitting for each subject. So we can type in t-test, and we want to compare B2 to B76 to C2 to C76. We want this to be a one-tailed test because we already have a prediction that standing should be higher than sitting. And we want to use a paired t-test, which is the number 1 here. You can look at this link, and if you want to use an unpaired test, where you have different groups of subjects in each condition, for instance, but we'll use a paired test. I can close the bracket, and so this is my p-value of my t-test. I also want the t-statistic, which you could use to look up the p-value based on the degrees of freedom. Degrees of freedom. Let's just say that that's df, and remember that that's the number of participants minus 1 in a t-test. The t-statistic, you use the equation t inverse, and you indicate the p-value and the degrees of freedom, and you get the t-statistic. So if we wanted to report this stat, we would say that the on average, the heart rate was higher in the standing condition, where the mean was equal to 83.2 beats per minute, and the standard deviation was equal to 31.2 beats per minute. And we could also say that the mean in the other condition was equal to 73.1 beats a minute, and the SD was equal to 27.59 beats a minute. We could say that the mean difference was equal to 10 beats a minute, and the standard deviation was equal to 30.9 beats a minute. So this is how we would write these in a paper where we were reporting the results of our experiment. And your assignment's going to be to write a sentence or two describing the results of our experiment and supporting that sentence with some of these graphs. So you could report that the mean in one condition, and then say this was higher than the mean in the other condition, say this, the difference on average was greater than 0. Then you could say that on average this effect was reliable, in that the t-value with 74 degrees of freedom was equal to 3.05, and p was equal to 0.003, which, as you can see, is less than the alpha value we might have preferred of 0.01. And we could also report our correlation. So we have a correlation where R was equal to 0.45. R of 75 participants was equal to 0.45. And so you could report all these things. The correlation, of course, tells us that our measurement was pretty reliable, that on average the measurement we got in one condition was correlated with the measurement in another condition, or that your heart rates are roughly the same when you sit and when you stand, with only this minor 10 beats a minute difference. Okay, I'm going to end the video there. That should give you a good indication of all the different ways you could plot the data and compute statistics, and how to report the statistics that you'll need for the assignment. And great job collecting data. It looked like the majority of you got nice clean data, and we easily replicated this effect of sitting and standing, even though it seemed like it wasn't working at the time.